Okay, so this will be the first finite element thing we do in this class. So what we'll do is we'll just do a really simple model uh, using C-rod elements, which basically are like truss elements. They don't support any bending moment, just axial loads. And we will use this to solve that wing strut problem we did in class on Thursday. Okay? Let me I forget the parameter, so I'm just going to pull up something on this other computer. Okay, so we're going to do it in hypermesh, solve it in OptiStruct, but again, most of these things also will carry directly over to doing it in Nastran, okay? So the first thing you're going to do is you're going to start hypermesh, and then when you start it, you will probably get a user profile window, which will look like this. This, depending upon how you want to solve, what you want to use as a solver, you have a different like profile. And so we're going to use OptiStruct. So you would select OptiStruct. But if you were to use Abacus, you could select Abacus or ANSYS or LSDyna or whatever. But we're going to use OptiStruct. So make sure it's OptiStruct is selected there. Okay. All right. So now we're ready to go. First thing we're gonna do is let's save the model. So we're gonna save as, and we'll make sure you use the model. We're gonna save the model, and I will put it here. I already got one going on. I'll call this strut 2, but you can call it whatever you want. Maybe strut 1 because you don't have one there probably called strut. Okay, it's usually a good idea to put all this stuff, put one model in one directory, because when you solve it, it generates a bunch of files. And if you have them all in one directory, like a bunch of different models in one directory, it gets confusing as to which output file is to which model, okay? All right, so you don't have to do everything in this order, but I think this is the best way to think about it. The first thing we're gonna do is create the material. Then we're going to create what's called a property card for the C-rod elements. So this is going to say, okay, the struts are going to be made out of the aluminum material, and then have these sorts of physical properties like the cross-sectional area, the J, and things like that. Then finally, we'll create the elements in a component level, okay? So, and again, you don't have to do it in this order, but this is the way I recommend thinking of it, right? Because the elements refer to the property, and the property refers to the material. So let's start right off with making the material. So we're going to make it out of aluminum. So we're going to right-click in this area here, hopefully. Wait, what is going on? Oh, I'm sorry. Click on model. Oh, it's because I had to move my screen around. So you should get something like this. I like to right click in here and do create, and you can create a bunch of stuff, but you can also go up here and create materials, okay? So I like to right click in this model window, okay? So I'm gonna right click in here and say create material. Again, most of these things are also up top. So let's give it a name. Call it aluminum. And we're gonna be in imperial units, pounds, inches, seconds, that sort of stuff. So we have to put in Young's modulus, which for aluminum is 10 million. So I'm going to put 10 e to the sixth. And then also a Poisson's ratio, nu, of 0.3. You have to put 2 elastic parameters in for isotropic elastic material. You cannot put in more, because if you know nu and e, you can actually calculate g. We'll talk about that later in the class. So if you put all 3, it sees it as an inconsistency. So typically I recommend using e and nu, okay? So then we hit enter, and now you've got a material card here. We'll use this term card. That's what people call it. It's a historical thing going back to when they actually had punch cards. And if you click on it, you'll see how the card is defined down here, right? Young's E and nu, and you can change the parameters, but for now, that's all we need to know, okay? So now I've got a material, fine. So now we're gonna make this property card, which I won't get too much detail why we have property cards, but like different types of elements have different types of properties. So for a truss element, really the only thing you have to do is say what material is it made out of and what's the cross-sectional area, right? Because really if you think about a truss element, or in this case what we call a C-rod element, that's the only thing that defines it. When we do bending elements like C-bar elements, we will have to define I and things like that, okay? All right, so again, I'm going to right-click in here, and I'm going to create a property. So I go down here to property, which is, right there. It's on the screen still. And I'll give it a name, and I will call it strut property, or strut prop. And down here are the parameters. So there's different types of properties, okay, for different types of elements. The default here is a property for a shell element. I mean, we're not going to use that. So we're going to change that to a P-rod card, okay? And it gives you a little warning here. Don't worry about that. Yeah, we mean to do that. So we're going to define properties for a rod element, okay? So again, first thing we need to do is define the material. So I'm going to select material, and it'll let me pick from the materials I defined. In this case, I only have one, so I'm going to pick aluminum, all right? So now that property has aluminum as its material. And then we need to define the cross-sectional area. So in class, we calculated that the area needed was 0.12 inches squared. So I'm going to put in 0.12 there. And you can also put in J if it supports torsion, or C to recover a torsional stress. But we actually don't need those in this problem. We'll talk more about that later, but we'll just keep it really simple. And that's all I need to do. Okay, so now I've got a property and a material. The next thing we have to do is define the geometry. We're going to define some points and connect them up with the elements, the C-rod elements, okay? So the easiest way to do that is to just type in the coordinates, okay? So, so what we're going to do here is to create geometries. Very often what you're going to do is you're going to import stuff from CAD, right? But in this class, a lot of the things we're going to do are really simple geometries. We actually will be able to create them directly in HyperMesh, right? But normally, right, you would import like an IGES file or something like that, right? We might do that once or twice, but normally we'll just be creating geometry directly in HyperMesh. And the way I tend to do that, again, as I mentioned before, on the upper panel here, you got most of these typical pull-down menus. But I've been using this program for so long that, they used to only have this little radio buttons things here. I kind of get used to doing this. So if you pick the different radio buttons, you'll see that these options here change. So to do geometric type of things, you click the geometry radio button here, and then it has geometry type of operations. It's similar like a pull down, but this is historically the way they did it. So click on geometry, and now we're going to define some nodes, and we get this new window, and there's several ways you can define nodes. These are all different ways of defining a node, but we're just going to directly type in the X, Y, Z coordinates, okay? So the first node I'm going to do is the upper wing, the leftmost point where the strut is defined. I probably should pull up the picture, but you remember what it is from class, right? So I'm going to call that 0, 0. So I'm going to call that 0, 0, 0, right? And I have zeros here, and I'm going to hit create. Did it create it? I don't know if I hit that button. Let's create it. And now you see I get this yellow tennis ball thing. All right. So now the next node I'm going to make is the one that's the point 4 feet to the right of it. Now we have to do everything in inches. In finite elements, there actually is no units, so you have to put in dimensions and material properties that are consistent with your units. So we used PSI for Young's modulus and whatnot. So that means that force is going to be pounds and lengths are going to be in inches. So if we go 4 4 feet to the right, that's 48 inches. So we're going to be at x equals 48, y equals 0, and z equals 0. We're going to create that point. And you probably can't see it because it's off the screen. So I'm going to click on this. Up here is like the auto zoom window, and now you can see it. So there's the 2 points. Now we'll go down below and create the points on the lower wing. So the first point is going to be directly below this 48 point, and it's going to be down 6.5 feet, right? So 6.5 feet is, what is that? 6, we're going to do it in inches, right? 6.5, 12 times. That's minus 78 inches, right? Let me just make sure I do that right. 78 inches, right? So we're going to go minus 78. And there you go. And if we auto zoom, you'll see here's the strut point right below it. And then we have to do the grid point that's the lower right truss point on the lower wing. And that's going to be at minus 78 in y, but 48 times 2, another 40 inches to the right. So that's going to be 56. I'm sorry, 96. 96. Right? 2 times 48 is 96. And so if I create that, you can see there those points. All right. Those are the points that we're going to connect up with our truss elements. Okay. Now, before I do that, though, well, we can always save. It's always not a bad idea to save. Before we do that, we're going to create a thing called a collector, which is, you can kind of think of it as like a level or a layer, right? So this is where the elements are going to kind of be stored. So you could have a lot of different elements, a very complicated model with like multiple parts and elements, different types of elements. And it might be easier not to have them all on one layer or one component level. It might be useful to keep them split up. So that's why they have components, right? For us, we're only going to have 3 elements, right? And so it's pretty easy just to put them on one, but let's still create it. So I'm going to create a component, and I'm going to call it struts, I guess. And when you do that, there's also a property that you can assign to it. That's more for solid and shell elements, so we don't have to do that here. When we make them with the property, it'll automatically be assigned, okay? But now we've got like this layer, right? And let's create the one-dimensional C-rod elements now. So these are going to be the actual physical elements. They're going to connect these nodes up, and they're going to use this strut property, right? Which is made of the aluminum, right? So that was why we kind of defined things in that order, all right? So to create the C-rod elements, right? These are what we call one-dimensional elements. So I'm going to go into here into this radio button where it says 1D, and that's going to have a bunch of menu options to do things to generate one-dimensional elements, okay? So we're going to make some rod elements. So I'm going to pick rods here. And you create them by picking 2 nodes. Make sure that element type here is set to C-rod. Sometimes it's set to something else like C-weld, but make sure it's set to C-rod, okay? So make sure that's set to C-rod. That's the type of element it's going to generate. And then make sure that the property is set to that strut property card, right? So that means now it's going to make C-rod elements using that property on the nodes that I pick. Okay, so let's create them, right? So first we're going to make the strut that goes from this node to this node. So I'm going to pick that node and then that node, and there it is. Now we're going to create the one that goes, the vertical one that goes from here to here, and then finally the last one, okay? So now we've got the 3 struts that are being modeled as C-rod elements. All 3 of those have the same property, so they all have the same cross-sectional area, and they all use the same material, okay? So if you had ones with different cross-sectional areas or different materials, you would have to define different property cards and assign those, okay? But we'll just have one type here. All right, so that's good. We can save it here. Now, the thing that we are missing is I need to put the lift and drag forces at the aerodynamic center of the upper wing. And that's, neither this point nor that point. So there's a couple of ways you can do that, but this is the way we're going to do that for most of these things. What I am going to do is not model the wing explicitly, but I'm going to put a node here that's going to correspond to the aerodynamic center. And then I'm going to connect that up to these points here, like where the wing would connect, using what we call a rigid element. So it treats like that, like as a rigid connection. So if it moves up, it doesn't deform, right? And so basically what we're assuming here is that the wing is much more rigid than the spars, which may or may not be true, okay? So first let's go back and let's create that node. So I'm going to go back to the geometry section and click on nodes. And now we're going to type it in. So remember this was 0, 0, 0. So X is 12, 0, 0, right? So that should give me a node that's 1 foot to the right of this node. Let's see if that works. There it is. So that's the aerodynamic center, right? That's where we're going to put our forces, all right? Now let's connect that up to the other here and here, and we're going to use the rigid elements, okay? So there won't be any stresses, they won't deform, they'll just rigidly transmute the loads. So that's also a one-dimensional element, so we're going to click the 1D button, and we're going to pick rigids, okay? All right, so make sure you have, we'll talk more about this, but have all the degrees of freedom clicked here. We're going to use RBE2 elements, make sure it's set to RBE2, and then we're going to pick the 2 nodes. So we're going to go from the aerodynamic center to that first node. Make sure you do it in that order, and then click the aerodynamic center again and go to the right node. And so now we've got those modeled as rigid elements, okay? They're the same color, but that's because they're rigid elements. If you want to, I think, let's see if we can do it. We can have them colored by, I think, configuration. Yeah, so if I change the coloring of elements instead of by part to by config, you'll see that they look different because they have different configurations. This rose color is for C-Rod, and the purplish is for rigids, okay? So that's what it is. All right, probably can save it again. All right, so we've got our models. In fact, let's get rid of these. We don't really need these tennis balls anymore. They're kind of like temporary nodes. So I'm going to get rid of those. So this is a weird step. So it's a good idea to do this before you apply boundary conditions. So we're going to get rid of the tennis balls. The nodes will still be there because they have to be there for the elements. They're going to be the actual nodes. So I usually just, okay, let me go back and say that again. Go to temp nodes, and then we're going to hit clear all. And all those tennis balls will kind of go away, all right? But the nodes are still there. We can pick. There's still one here and whatnot. All right, so there we go. So now we've got the geometry model with these 3 rod elements and then the 2 rigid elements to model the wing. The next thing we need to do is apply boundary conditions. So we're going to have to say that this node down here and this node here are fixed, and then we're going to have to put the forces up here at the aerodynamic center, all right? So I'm going to stop right now because I always go long and then I screw up the video and I don't like to re-record everything. So I'm going to stop here and then do another video where we add the boundary conditions, okay?